Hi, my name is Holly Yantel. I am an independent researcher, and this video is part of my application package for a model designer with OpenAI. My goal with this video is to actually get the attention of Sam Altman because I'm trying to cut through the unrealistic hype and of AI and design relevant applications of this technology. And I really share his vision for a better society and using technology, especially AI technology, towards creating a better society that eradicates disparity, things like poverty, and shares abundance for all. There are so many ways that we can apply this technology if we look at it through a realistic lens. And I can see kind of his frustrations and his vision with the stuff he and OpenAI put out there in terms of where they're going. With AI technology. And I think the kind of math that I do has really great potential and application within AI. Even though I'm not formally trained in computer science, I do have academic experience in psychology and some other sciences, as well as some math talent. And My independent research focuses on discrete math, primarily with Boolean logic and Boolean algebra. I'm really good at creating those intense philosophical questions that kind of bifurcate people into one or the other and discovering where those kinds of spectrums can be located within human behaviors, decision makings, and the human experience, um, as well as using other abstract ways to apply logic in order to describe life. In cool ways. It's really fun. So I will get straight into this presentation, which is about strategic opportunities in AI modeling. So, like I said, I am not really well versed in computer science. That's not my background, but just kind of having a competent understanding as a user of ChatGPT, for example, and following the press releases of technology and kind of keeping up with those articles and stuff like that. So I consider myself relatively well informed, though I am not in the industry yet. Um, So I did not complete school. I would like to complete my PhD. That is my educational aspiration. Um, but so far, I'm a little bit over halfway to a bachelor's. But I'm a very fast learner, and I was really good while at school. I had a 4.0 throughout community college, and then 3.6 while I was at University of Michigan. I was in honors at University of Michigan, so those courses were all much more accelerated and difficult. So psychology and cognitive science were all considered honors as well. So those were difficult classes. Those were a lot of fun. Um, I can locate behavioral predictions. So how I've done it so far with psychology is like I predict a codependent person's behavior versus an independent person's behavior. Given a situation, what will a codependent choose versus an independent person? So that's where my math and logic is applied to decision making. So I try to locate behaviors and pathologies and predict how people would act given certain situations. Um, and can't see what that last thing was, but I know it was an important note. So yeah, I'm a digital native who keeps up with technology, press releases, and kind of keeps up with the buzz online about AI and stuff like that. And I've used it for a while, and I've really been curious about it, trying to understand what it is and how it works. And I've done a lot of self-study on that. Um, my overall philosophy with technology and what I'm trying to do with my life in general is that AI and all technological progress should be dedicated towards eradicating all harms in society and distributing all global abundance equitably. Um, that just is my vision in a sentence. But I think that, all of our existing technology and ingenuity can be applied to fix the innumerable problems we have in society. And it's frustrating that it hasn't been done yet. Um, I think there's this hype surrounding AI that it will take us, to completely flying cars and stuff like that. before we eradicate things like poverty within society. And I think that's kind of an absurd idea. Um, I go a little bit more into depth into this within the presentation, but I think that there's this idea that it's going to replace human progress. We can just rely on AI for progress, but I think it can help us create progress, but it can't create the progress for us. And that's the biggest misconception with AI, that it will create progress for us. And I don't think that's true. I think it will help us create progress, but we ultimately have to create our own progress. And we should ultimately start kind of applying the technology and the resources and ingenuity that we have towards eradicating problems rather than creating, novel new toys in a very late stage and corrupted capitalism. Always about new, 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 instead of just let's fix what we have and deal with what we have. Um, So just kind of my outsider view of how it seems like a neural network kind of works. The user enters a prompt. It's called the attention mechanism layer. It filters out the prompt for the most relevant words, so like what the neural network should be searching for. Then it goes to the neural network. And from what it looks like, and I don't really know because I don't have a background in AI, but it looks like it just kind of searches for like relevant, articles, books, and stuff to go base off of. And then it creates probability based upon what it knows from general training, but um, with respect to the relevant data sets it retrieved based on the query. So it does word prediction. It kind of looked like to me like it looked like AI kind of looks like to me like glorified autocorrect is how it's kind of described to me. Like the autocorrect function on our phone, which I think came out before AI, that kind of function is what AI looks like. So it's just trying to predict words based on data sets of books, articles, stuff like that, wherein these words occur with a certain pattern. So it's trying to, word patterning and predicting the next word based on word patterning, given the word patterning of however many texts it uses. Um, and then it all comes together logically to give a coherent output. Um, and it seems that the most of the complexity of the underlying technology surrounds that word prediction. And then also the retrieval and scanning of the data sets in order to update how those words should be predicted. Um, Seems like where the complexity is of it. So I'm a fan of Rick and Morty. This is a funny episode. It creates a robot. Its only purpose is to pass butter. It has a little existential crisis. Um, so looking at AI, if one should ask, what is the purpose of AI? What does AI primarily get used for? And I would say that right now it gets used for locating the truth. So to answer questions, gather information, or find the truth. So, and it's also like trying to gear towards getting us progress, like getting scientific progress for us, locating truths beyond that which we have located ourselves, um, and finding out answers that we haven't and stuff like that. It seems really dedicated towards that, in a way that doesn't seem to have produced much results in terms of, you know, stuff that is useful. Um, So that's what I argue the primary is for, is to locate the truth. And it's made difficult because the training data involves bad information. And so I'm sure, I don't know how it works, but I'm sure there is some, added algorithms and functions put into AI because it has to disentangle good information from bad information, stuff that's true versus not. Um, and so it having to constantly verify and validate unnecessarily instead of just having a reliable data set, um, puts unnecessary work into the whole process. Um, and so the whole hype with everyone talks about data and more data, more data, more data. You talk about like phone data that people get, and apps that are constantly getting your data, and that gets used for marketing and it gets sold, and people are doing so much with data. and it has to do with prediction and betting and all of that stuff. And everyone thinks more data can make better predictions. Um, so I can only imagine that this more data can create better predictions philosophy is also found within AI. Uh, so I don't think that's true. I think better qualified data creates better predictions. So I think even when I apply this to like capitalism marketing, and I'm like, if you can just survey your customers, you don't need all their data that you get from the app. You just need survey information, which is better qualified information to know more about them in a way that's relevant to their purchasing history with you. Um, so how this would apply to AI is that like it doesn't need, thousands of textbooks. It needs, the most accurate and well-written textbooks to refer back to instead of going back and making all this probability based off of several texts. It can just make probability based off of a few like really good texts and determine, outcomes of inputs that way. Um, because whether or not like, you know, 100,000 texts say the quick brown fox jumps over the lazy dog. It was part of a AI training article I was reading. It was talking about the cat jumps and lazy dog. And I was like, oh, it's from that. Um, but if you want the output, if you say the quick brown fox, you want to say jumps over the lazy dog, you don't have to have it refer back to 100,000 different instances of that sentence occurring. You can refer it back to 10 instances of that sentence occurring, and it would know to do that. So why it relies on so many instances of something occurring in order to get that probability, I'm not sure. But I think with condensing it and streamlining it, there's a really big opportunity to have like better management of the data flow and the data being used with an AI technology so that it uses less, but what it does use, it gets more out of because that data going in is more qualified, it's more valuable, and it's already like presumed as truthful. So you don't have to go in and like have to validate whether or not it's true. It can just be presumed true and work with it. Um, so yeah, I don't see why I would need to use, you know, 100,000 instances of a sentence rather than one, two, or 10 instances of a sentence to know to predict something in a certain way. Um, so if we kind of like go beyond, like how can we do truth seeking in a more applicable way, in a moral, real world in ways that have real world application. Um, so I see a lot of potential for AI in terms of archiving, organizing, correcting, and prediction. And I think these can be kind of four different categories where there's a lot of potential. Because I think AI models now try to do these things, but they don't do them that well. Um, I think the biggest use of AI is for exams and college and cheating, probably, on that kind of stuff, and easing the work that goes into schoolwork. Um, you don't want to do schoolwork, don't go to school is what I say. So it's kind of being used a lot for that. And so a lot of its benchmarks, like humanities last exam and stuff like that, is basically like college exams. It's tr being trained on being really good at taking college exams. Um, And so that is being applied and being hyped up as like being the answer to, if we accelerate this, it'll get us to the moon or whatever, metaphorically speaking. But because it has that kind of like primary goal of truth seeking and stuff like that, and that's what these models are primarily based off of to do, these large language models, um, they they get limits really quick when you try to apply them to basic stuff like AI assistants within business organizations and stuff like that. There can be a lot of limitations and frustrations because um, it's not really built to do these things. Um, while it uses prediction, it's not really like that phenomenal at prediction. I mean, it's good at prediction, but there's so much prediction within it. It could be better at prediction if you take out a lot of prediction from the like redundancies and having to reference so much data and stuff like that, and apply that prediction elsewhere in the process to create better prediction. Um, but so this, I define static truth as like any truth that's always present. So like math, physics, and then emergent truths are truths that didn't always exist or can be changing and stuff like that. So, if information isn't found yet, so like correcting, it can emerge. Um, if you how I'm trying to apply this to psychology, my medical theory of psychology, trends can emerge, if we start qualifying people as, cluster B personality defined and stuff like that, trends can emerge, stuff like that. So that can be like new information that comes out. Um, I think everyone wants prediction, um, and thinks that more data equals better prediction, but I think better data equals better prediction. So I really want to get involved with, wherever I can apply uh, these kind of logical qualifications in order to get better data. And yeah, I've seen in like recent Google AI advertisements, like kids, like middle schooler or high schooler taking a photograph of y equals mx plus b equation. It was like to find y. And it brought up a Google page on how to do it. And I'm like, oh, you're revealing exactly what's going on with your tech, huh? Uh, And then even adult use for it was a guy walking by a flower box and he took a picture looking up to a flower it was. So he gets some for himself. So it shows that like AI is really, really seen as a truth seeking kind of thing. But I think these four applications can be done in a lot of different ways that are really cool and also combined. Um, so it seems like when it comes to prediction, they care about filling in these variables, not necessarily the quality of the data, but the quantity of having a lot to fill in. So it can be reduced to a final output. I use a March Madness bracket as a good example of Boolean. The odds of having a winning bracket are 1 in 9.2 quintillion. It's a lot. But there's so many ways that these people can be placed, or these teams can be placed rather. Um, and so where the big data hype is getting a lot of data points outright, for me, I'm like, well, let's get better qualified data because it's like 1 in 9.2 quintillion with these. It's like, you know, if this versus this outcome is like a really cool, uh, has a really cool meaning, like in medicine, for example, you could have it be indication of a fever or not, for example. And then that could indicate something. But like qualifying, this is a little bit different than how I've used this before when it comes to medical stuff, but how you qualify things throughout the kind of binary process, win or loss in this case. Um, but qualifying the initial information and refining it and make it better qualified data instead of more data, I think is key for doing more with less. Um, yeah, so I just thought of randomly today how the final four bracket is like the Boolean algebra in action. So I don't know what's currently used in the field in terms of terminology, so I kind of like make up my own stuff in order to describe it. But I think I'm like describing it fairly well, all things considered. Um, what I'm trying to create is a situation specific model. So first of all, I talked about on the previous slides is it doesn't to get the same amount of information, it doesn't need, a duplicated redundant instances of a sentence to understand a sentence. It needs minimal understanding possible. So it would be creating the basic kind of data set minimum for accurate use of English, for example. I know English only, so I could only do it for that, but the accurate use of English or another language in a conversation in formal writing. So base data set that can understand the English language in conversational or formal writing. Um, It has like generalized knowledge of things. Um, and then additionally, the next layer is situation specific training data that pertains to a use purpose or field. So this reduces the number of data sets being used in the training data. And then the use cases can be more specific and they can be kind of designed in accordance to alignment. So you can align a model if you're using it for like a research facility in astrophysics, for example. You can design a model like we're going to get this kind of data from near Earth objects or something like that. Um, Here's what we're going to want it to do once it has this data. And then other types of studies like that could emerge and stuff like that, but just the kind of flexibility to adapt to training data that's done by intended use. So intended use training is that like, if this is a model created for an astrophysicist institute, then scientists using this model will train it and make it smarter. Um, because of the data that's getting put in is better, more qualified data. And so they can use it to log like experimental results and stuff like that, and use it to even like get data uh, from like satellites that are monitoring stuff like that. So, and another thing too, is not just like all possible prompting. So with ChatGPT, most of it is like you can ask it anything. And so this eliminates that. So it's like you have different fields that you will put in for different types of data. So it would only work with and use different types of data and give output responses uh, based on the data, situation specific data that it has. Plus its general access to like the generalized training data. It uses that to help make the specialized situation specific data flow more coherently. And it can be applied to like, spreadsheets versus, creating tables and data and stuff like that. Um, and then each model will be kind of different for each one. Like I would have my own model for the medical theory of psychology, um, that I could like my goal with it would be able to create like a tool for like public health use where people could go in and like do different types of journaling and stuff like that, where there's like strategic goals and metrics and like advice it gives you and stuff like that. And then, taking personality quizzes and other like health quizzes, um, to discuss a little further. Um, so I kind of created my own kind of pseudo modeling because I don't know the formal way of doing this. I don't want to call it modeling. Um, but this is just, I create a lot of I create the functions are the easy part of what I create with my diagnosis. I use the same functions. I use one function for falsifiable tests, which eliminates one of four not occur or something not occurring. In the other three instances, there's something occurring. Um, or I use a what I call indicator test, which is something is presumed indicating, and so it's presumed occurring. So it's 1 through 4. Um, doesn't eliminate anything, but it shows a range of something occurring. Um, and so this is just the function for the CV score, uh, which is 2x plus y, I think. Yes, there it is. Yeah, 2x plus y. Um, and so function is CV x1, y1, 2x plus y. That is supposed to 2 plus 1 is 3. So yeah, CV3 cluster B personality. Um, so it can go through, locate, where they answered on these quizzes to get the result, what their X value and Y value was. X refers to the most important diagnostic question, and then Y refers to the second most important diagnostic question. And it's either like yes, no, true, false. Is it this or that that's occurring? Stuff like that qualifies it. Um, and I'm not sure it's called like when you send like a prompt or a ping out into the neural network to gather information and to come back. I call it a snowball, is my little name for it. So it kind of just snowballs out, gathers information, and then retrieves it. Um, so this would be like for my diagnostic questions, a way that it could pull up the results, kind of in pseudocode or pseudo modeling. Um, So I'm going to read this last paragraph. I think it's very poignant and it captures a lot of what I'm trying to convey here. And it's that a lot of hype surrounding AI and technology includes a misconception that it can accelerate science and other progress faster than we can. When I believe a more accurate stance is that it can help us progress faster, but it cannot create progress for us. We should leverage our vast abundance of existing brilliant technology for the greater good and instead focus on creating our own progress and do so with ease using the help of AI tools. So I think a lot of the hype surrounding AI is that it's going to, create progress for us. I don't think it can. I think we really do have to create our own progress. And but it can help us. It can be a great tool to help us organize things, do better research, do better science. But we still have to do the science at the end of the day. But it can really help us with so many different applications. But I think the first step is looking at it, beyond truth seeking, finding an answer. What are we trying to use it for? And how can we better apply it towards that use by streamlining where it gets used elsewhere in terms of compute and what's going on in the neural network? How do we make that easier? Um, and so when I've looked at like how the different types of neural networks look like, nothing looks kind of like strikes as looking very Boolean, like kind of how the March Madness bracket looks very Boolean. Um, but how they describe neurons within neural networks, I would guess that's where Boolean takes place the most, but I'm not sure. Um, but there's so many ways to use multivariable Boolean logic and ways. I think to be frank, I think that the way it's done right now is lazy. I think it's this we have so much data, how can we organize it using LLM logic and AI logic? And I think it's just instead of refining the data and make it better, it's just throwing everything in and hoping it'll, an output will come out that, will change everything. And I don't think that's realistic. Um, but I do think it can be applied in many cool ways and like really help achieve progress um, and build progress. And I think, philosophically, one of the things that holds us back is that we don't apply existing technology to eradicate things like poverty and disparity and all these problems on this earth. And we can create a utopia. We can create such a better world. And we don't. And I think until we do, we're not going to see these hyped up frontiers of science and technology that, uh, some people might claim are happening. I don't really agree with the accelerationist movement or ideas or a lot of popular themes within the technology community, but I am very fascinated by technology and how it's done. And since I've started, discovering my talents at discrete math and Boolean algebra and the math that underpins computation and computers, I'm really excited to see where I could take this in terms of, you know, uh, doing science with it. It's really exciting for me. And um, I think it like what I'm proposing can be done. It's just I don't know why it's not done. I can't say I don't know why. I think maybe it's just the hype and the hope that giving something enough information will, produce something that was completely unknowable before or something like that. I don't know. But I think there are a lot more realistic and cool applications of AI. And of course, once we like start eradicating the problems of our society is when we can really start launching a new frontier. Um, I think it really starts with eradicating the problems. and unnecessary suffering on this planet. And then once that's done, we can really, once we have all the brain power, at the table, so to speak, we can really start applying these technologies to actual new frontiers in science and beyond. But with the kind of like fix the ill health of, human civilization and people first before we can move forward, I think. And that's really my personal ambitions with medical theory of psychology and using AI to make it a public health tool is part of that whole philosophy, trying to make the world a better place and a cooler place to live, more fun. Um, so thank you so much for watching, especially if you've watched till the end. I'm really happy to schedule a meeting. And of course, I'm really open and hoping for any opportunities with OpenAI. So, and also I am an independent researcher that's in between jobs. So any donations to my Cash App are also welcome at #HawkandCrow 420, my awkward outro. So thank you so much for watching. I really hope to get somewhere in research soon. Thank you.